a polynomial that is in factored form. And you'll see it up here. I'll highlight it for us. Y equals x times x minus 3 times x plus 5. And it's a polynomial, and it's already in factored form. And I want us to be able to look at it in factored form and recognize a couple of things. First, do we know what the degree of this polynomial is? Anybody want to take a guess what the degree is? It has to do with the number of x's that you see. So how many x's do you see? 3, which actually means the degree is 3. If I multiplied x times x times x, wouldn't I get x to the third? So that's why the highest power would be 3. Therefore, the degree of this polynomial is also 3. It just happens to be in factored form. We were graphing things up to this point in standard form, weren't we? So it's actually a little bit easier to graph when it's in factored form. So we know this happens to be or have a degree of 3. Okay? So when it's in factored form, we can find what we call the zeros of the polynomial very quickly and very easily. And we did this back in the quadratic unit. What did we do with each of those factors to solve for the zeros or the roots or the x-intercepts or the solutions? What did we do? We said each of those factors equal to what? Good. So we're going to do that here as well. We're going to take x and set it equal to 0. So what does that mean? 0 happens to be a solution, an x-intercept on our graph. I'm going to take the next factor, and I'm going to set, x minus 3, I'm going to set it equal to 0, and I have to solve it. So what does x equal? Try again. X equals positive 3, which means that positive 3 also happens to be a solution or an x-intercept of the graph. When I take x plus 5 and I set it equal to 0, what does that tell me? That negative 5 is a solution to the graph. So those are the roots, or the zeros, the x-intercepts. What do I know about the end behavior of this function? Are there any negative leading coefficients here? Anything out in front that would imply a negative? No. The degree is odd. We have a positive leading coefficient. So what do I know about the ends of my graph? Are they both up, both down, one up, one down? What do we know about an odd degree polynomial with a positive leading coefficient? The left is what? Up or down? The left would be down. And the right would be up. Remember what I said. When it looks like, when the degree is odd, they're in different places, the ends are, right? So that means that we there's a lot of stuff happening in the middle, and we'll get to the middle in a minute. But if I just worry about the ends, you can kind of think about it as a positive slope. I know there's going to be humps and curves. I'm just talking about the ends. It kind of helps me hear better. All right, so now what I need to do is kind of connect the dots. And I don't know necessarily how high or how low those bumps go. And we know how to find those max and mins, don't we? We did it on the calculator, didn't we? And it's fine to do that. So we're going to kind of, at this point, just estimate. I know, can you kind of visualize that we're going to kind of go up, down, and up again? Would you agree? Just kind of connecting the dots. And again, I don't know necessarily how high or how low those go. They might go really high and really low. They might not be very high at all. But I know that that's the general shape of the graph. Would you agree? So I'm just going to tell you that these are kind of estimates right now. How would you find exact? You know, like what you did on your OPQ today. Would you agree? Just calculate the maximum, calculate the minimum, and you find those points. And that's okay. So what we're going to do for today is we're just going to find the zeros, and we're going to graph. Pretty easy, not too hard. Okay? So let's look at a different one. So when it's in factored form, we can find the roots, we can look at our end behavior, look at the degree, and kind of connect the dots. what I'm looking for right now. No calculator right now. Okay? So let's try a different way. Let's actually write an equation from its zeros. So again, over here we were given the equation, we had to find the zeros. What if I gave you the zeros and had you write the equation? Could you go backwards? Let's see. Let's look at the relationship. X equals 0, I know x is a factor. X equals 3, what's the factor? X minus 3. If negative 5 is a 0, the factor would be x plus 5. So aren't the signs different on the inside of the factors? So that's kind of what we're going to be looking at here. Okay? So we're going to write an equation given the zeros. So in this particular case, I've given you a couple of things. And it's important that you look at all of those words. One of the key words here is quadratic. What does quadratic mean? The degree is what? 2. Which means I'm really just going to have 2 x's. Okay? That's important information. I also know that I have some zeros of 3 and negative 3. Okay? So, could I write an equation? Okay? There are actually many equations that fit this information. Let's come up with one, a basic one. All right, let's come up with this one. Would you agree with that one? Yes or no? If 3 is a 0, isn't x minus 3 a factor? And if negative 3 is a 0, isn't x plus 3 a factor? Perfect. This is okay in factored form, I agree. Okay? That is one of the possible answers. But could I also put a negative out in front? Would it change the zeros? Would it change it from being quadratic? Nope, that's a possible answer. What if I put a negative 4 out in front? Would that work? What if I put a positive 5 out front? Would that work? What if I put any number I want to out in front? Still doesn't change the zeros. Do you agree? Still doesn't change that it's not quadratic. So there are an infinite number of solutions or answers to this. But I'm going to add it a little bit. This is going to change the notes a little bit of what I gave you, okay? So I'm going to add some more information. I'm going to say, what if, and it's giving you a p of x for some reason. I'm not sure why I chose p and not f, but I'll stick with it. What if I said this information? That's additional given information in the problem. Okay? I'm telling you that it's going to have zeros of 3 and negative 3. It's going to be quadratic. And then you have p of 0 equals 18. What does that mean, p of 0 equals 18? What is that? What is that information? It's not a 0. It's a point that's on the graph. What point is it? What are the coordinates of the point? My input is a 0 and my output is 18. So what point is this that's on the graph? 0, 18. So that isn't that just the y-intercept? Do you agree? The y-intercept? When we talk about a polynomial in standard form, the y-intercept is always your last number. Okay, it's that c in a quadratic equation. So I want c, the last number, the constant term, to be 18. What is the constant term right now before I do anything? Well, I'm not sure. If I didn't change anything right now, how could I figure out what the constant term would be? Let's do some work to answer that question. So, let's go ahead and multiply. Could I use FOIL? To say x times x is x squared, x times 3 is negative 3x, positive 3x, and negative 9. You with me so far? That's all I've done. What's the constant term here? Negative 9. What do I want it to be? 18. So that means I have to put a number out front, don't I? So what number can I multiply by negative 9 to get 18? Right. Now, a lot of you can do it in your head, but sometimes, what if I said 5 here? And I gave you like a fraction number. So let me show you an exact way every time to answer that question, okay? I love that you know how to do that in your head, but because you know that -9 times -2 is 18, you can answer it, but sometimes the number here is not so pretty, okay? So all you could say is -9 times some number is equal to 18. What if I said 5 would be 5? I don't know, whatever that number is. So your constant term times some number is equal to 18. And then I would just solve it. Divide by -9, and that's how I got -2. Okay, so I know that that would have to be my number. -2 has to go in front in order to satisfy that condition. So that would be the full equation. Okay? I think we should try another one like this, don't you? They're a little harder. So we can do another one to try. Let's try. So let's say that I'm giving you zeros of -2, 3, and 1. And I'm also telling you that I'm going to use f of x. F of 0 is equal to 10. I know the answer is going to be fractional. So how would I come up with the equation of this particular polynomial? We use our zeros to write the factors. Let's start with that. And then once we have our factors, we're going to take and figure out what our constant should be. Take a second to write the factors down first. So give me one of the factors. When you give me one of the factors. Yeah, you're going there, you're doing. Now x minus 2, the signs change, will be x plus 2. Very good. The factor sign and the zero sign are different. Give me another one, Alexa. X what 3? X minus 3. The factor and the zero have different signs. Okay? And go ahead, Brianna, give me the other one. X minus 1. Very good. So I know that that is the equation that I'm looking for. Well, maybe. It's one of the equations that goes with all of those zeros. I need to figure out if I'm going to have a number in the front. Is my leading coefficient going to be something other than 1? And that's really what we're looking for here. We're looking for what number goes here, right? And this information here tells that to us. It tells us the point 0, 10, or 10 is the y-intercept. Well, what is the y-intercept right now? Well, I could do a lot of work and multiply all of that out. But honestly, if I just multiply these numbers together, it'll give me the y-intercept. So what is 2 times -3 times -1? 6. So right now, the y-intercept would be 6. Is that what I want it to be? No. I want it to be 10, don't I? So right now, it's 6. So 6 times something, I'm going to call it a, because it is a is a leading coefficient. 6 times some number is equal to 10. Now, can you do that one in your head? A little harder, don't you think? So how do I solve it? Divide by 6. So what is 10 divided by 6? 5/3, or 5/3 is fine. Leave it as a fraction. I like that. It's not an exact decimal. Right, Josh? Good. So I'm going to put 5/3 out here in front. And that is my equation that I'm looking for. It's the equation that satisfies that. Could you graph it? Your calculator would help. We would go ahead and do an estimate here. We're going to graph the zeros. Would you agree? So we're going to graph -2. We're going to graph 1 and +3. -2, 1, and 3. What does my end behavior look like here? What's the degree of this polynomial? 3. Got 3 x's. The degree is 3. So that means it's odd, which means the ends are up and down. Is my leading coefficient positive or negative? positive, so I know that my ends do this. And I'm not sure exactly, except for I know my y-intercept is up here where? At 10. I'm just going to put it up there at 10. I know it kind of looks like that. Would you agree? Something like that. Again, we're estimating these max and mins, aren't we? Those are rough estimates. Okay, good. All right, I got one more for you to try, and I'm going to give you guys some problems to work on, okay? So, I've introduced a new word here. Same type of problem, but with a different word added to it. Okay. So let's start by just writing what we know, okay? So write down, you know what the zeros are going to be, you know all that stuff. So write down the factors, and let's see what we can do from here. Give me one of the factors, Jasmine. What do you have for a factor? X minus 2 is definitely one of the factors. I 100% agree with you. X minus 2. Okay, what else do we have? X plus 1. Totally agree. Now, when it says multiplicity of 2, all that means is that factor happens twice. That's all it means. Okay? The factor happens twice. And honestly, we can just write it this way as well. And that's okay with me. Now, when I have a double root, that's what that means, double root. Do you remember what that looks like on the graph? What does it do when you have a double root? It just kisses that axis and goes back up, doesn't it? So that's going to happen in -1. So when we graph this, you're going to have to pay attention to that part. Now, I'm not finished because I still need to figure out if I have something to put here. Do you agree? So what am I going to look at for that? I'm going to look at my y-intercept, or the point 0, 6. Is also the y-intercept is equal to 6. It can be written in any of those three formats, okay? What is the y-intercept right now? -2. And I don't want it to be -2, I want it to be 6. So, -2 times some number a, which is our leading coefficient, is going to be 6. So if I divide by -2, I know that my leading coefficient should be -3. Very good. So I'd like us to graph a sketch of of this. Go backwards today. Let's go ahead and try to graph this. I keep saying that. Sketch it out. Yes. Where did you say because I knew, remember, what your current y-intercept is, we take these numbers and multiply them together. Okay? And right now, it's -2. And we want it to be 6. Good. Discussion? No question. Almost right. Okay, so let's do a little sketch here. I'll see if I can come up with my graph real quick. Looks like I can. So what does the graph of this look like? Well, let's start with the zeros. I have 2 as a 0, and I have -1. Now, what happened to that -1 again? You just kissed it, right? So, how about end behavior? Both up, both down, 1 up, 1 down. 1 up, 1 down. The degree is 3. Do you agree with that? The degree is still 3. I have 2 x's here and another x here. So I have 3 x's. So the degree is 3. If the degree is 3 and the leading coefficient is negative, what's happening with the ends? What's happening on the left? Is the left up or down? The left is up. And how about on the right? Is left up or right up or down? Good. So I know, we're going to kind of just estimate here. We're going to come down here and kiss the axis. What was the y-intercept? No, I wanted it to be 6, I think, right? So 1, 2, 3, 4, 5, are estimates. The only thing I know for certain are these 3 points. Would you agree? So when I have a multiplicity of 2, it kisses the axis. There's another multiplicity sometimes you can have. What would a multiplicity of 3 do? It means that factor happens 3 times. It's a flattening out point in the graph. Remember how sometimes the graphs look like that, right? Where this would be a maximum, and this would be a flattening out point. So that flattening out point is going to give us a root. It happens flattening out at that 0. So rather than kiss the axis, it would kind of flatten out at that point like this. Okay? So if it says multiplicity of 3, note that's what you're going to do at the 0. Question, Amy?
Yeah, so you know it's like up because the leading coefficient is negative.
I know that the end behavior is one's up, one's down because it's an odd degree. I know that it's the left is up and the right is down because there's a negative in the front. Any odd degree polynomial with a negative leading coefficient has this end behavior. Okay? I could also check it on my calculator, couldn't I? When you have a calculator, it's not going to take it away from you. You can always check it. But you want to be exact about these portions of things I'm telling you, okay? All right, so let me go ahead and give you what I'm looking for you to do today. I do have a place for you to graph, and I didn't provide a graph for you, so you'll just need to kind of do a little sketch of the graph. Be real careful about the zeros and the y-intercept if it's needed. So please make sure you add this 5, 6, 7, 8. Just add this information. To your 5, 6, 7, and 8, okay? You guys, several people have asked me the question about, they're confused about when it goes up and when it goes down. So let me summarize real quick. This is what we did a couple of days ago. Shh, guys, listen. If the degree is odd, it either goes like this, or it goes like this. That's the first thing in the packet that we did. If the leading coefficient is positive, or the leading coefficient is negative, if it's positive, it does this. If it's negative, it does this. So odd degree polynomials, negative leading coefficient. That's my end behavior. Odd degree polynomials with a positive leading coefficient, that's my end behavior. When the degree is even and my leading coefficient is negative, they're both down. Or if it's positive, they're both up. So hopefully this chart can help you a little bit. Kind of summarizes everything, and that's what we did 2 class periods ago, with that like table of charts that we did. Okay, so maybe that'll help a little bit.